Right, so recording is now on. You'll see that on your various devices. I'd like to welcome Eldridge Alexander from Duo Labs. So welcome, Eldridge, to the call.
Thank you.
Duo Labs, I understand, is a Cisco company. And Eldridge presented at Black Hat USA last week with a terrible pun on dough. I think probably the worst one I've seen so far about kneading the dough. So well done for coming up with that. So I thought it would be useful, given I know many of you weren't actually present at Black Hat last week. So I asked Eldridge if he'd be so kind as to reprise his sort of presentation, which talked to some of the perceived challenges around dough, and also gave his take on how well founded those perceptions were about it. So without further ado, I'll hand over to Eldridge. If you wish to, Eldridge, you can share your screen if that helps matters.
Cool.
But without further ado, then over to you, and look forward to an interesting chat.
Cool. Thanks so much, Andrew. Appreciate it, and I appreciate the invite. Yes, well, as Andrew said, I am on Duo Labs, which Duo is now a part of Cisco. I think I have to say that every time I say Duo now. I think our official company name is Duo, now a part of Cisco. But yeah, so I'm going to go ahead and share my screen here. Oh, Zoom needs preferences from macOS. Of course it does. One moment. I must have reinstalled Zoom at some point. So while I'm doing that, I will preface this a little bit with, oh, that was easy. All right, can everyone see my screen there?
Yeah.
Cool. So yeah, just to preface a little bit, I presented this on the corporate security track at Black Hat. While I am on a security research team at Duo, most of my background is in corporate and enterprise IT, where of course Encrypted DNS plays a bit of a role there too. That's where a lot of my experience is coming from. Given the nature of this group, the intro here was might be a little recap-ish for y'all. So I'm going to speed up a little bit for the first part, but do feel free to stop me if you want me to slow down or have any questions. So first off, I just wanted to talk about why DNS, why at all. Dr. Makapetris and John Postel created DNS in 1983. It does just what it says on the tin. It changes the name into an IP address. Prior to that, there was a hosts.txt file that was regularly distributed to every host on the internet. As the internet started to scale, this was untenable. So DNS was a distributed system that was put out at the time. And it was unencrypted from the get-go. And according to Dr. Makapetris, the fact that it doesn't have much security was intentional because folks were already struggling to accept the idea of a distributed system at the time. And so any barrier to entry to DNS was something that was a kind of a no-go at that point in time. So one thing I wanted to talk about is at least my perception as to why DNS encryption is relevant now. So you've got, it was invented in 1983. HTTP didn't become even released widely to the public until 91, and HTTPS was on the scene in some capacity about 10 years later. So why are we now focusing on encrypting DNS 37 years after the initial DNS? And mostly, in my view, this is due to a couple of things. One being HTTPS and the ongoing adoption of HTTPS with TLS 1.3, which I'll get into in a little bit, and the fact that it has ESNI. So just I want to walk through what DNS or what information from a user looks like to someone sitting on the middle of the traffic. And at least for this part of the talk, I'm going to make no judgments about whether people sitting and viewing the traffic are benign or malicious. Obviously, one of the big concerns around DOE is, do you have something that is benign, like a network operator, like your enterprise network that is managing the network for your enterprise endpoints? or is it an ISP that might be harvesting, selling, manipulating your data? That's problematic. So this was when HTTP first started out. You would send, and the green box indicates that someone sitting on the line can read the unencrypted information traversing it. So first, the DNS request for google.com, the IP address comes back, you send the HTTP GET request, and you get back your HTTP response. So this is what happened in the early 90s when HTTP came on the scene. The web became an easy way for people to access internet resources and people that were perhaps less technically inclined than some of the other protocols. This obviously coincided with more financially accessible personal computers and a lot of other things came together to make this prominent. And one thing that happened was more and more things were pulled into the HTTP protocol. While you have all of the original protocols, of course, still exist, it is rarer for people to be using things like POP and SMTP to access their email directly when they might use webmail clients. New APIs are deployed over REST or other HTTP-based API implementations. XMPP, for example, still exists as a chat protocol, but people are mostly accessing it via Google Chat. Well, probably not Google Chat anymore, but are typically accessing it over web-based clients. New video conferencing systems, Zoom included, is moving to things like, or has moved to things like WebRTC. So HTTP started eating the world, and HTTPS became a primary point of concern. So you can see that over the last, 5 years there, we've gone from, depending on which platform you're measuring, from 30-ish% to around 90-ish% of the web has moved from HTTP to HTTPS. So now we go from this diagram to this diagram. So the contents of the HTTP request are encrypted and not available to anyone reading line traffic. Now, another thing started happening since the days of the early web, and one of that is reverse proxies. Now, you're primarily going to see this in edge networks like Cloudflare, Fastly, Amazon's CloudFront, Google's Edge caches. There's a lot of CDNs out there. And so the actual IP address, the actual IP address that you're going to is not as useful of a piece of information. So, of course, the IP address is still visible to anyone that is reading line traffic. So in the days before CDNs were quite as widely utilized and deployed, the IP address was actually a pretty useful piece of information on its own. You could do not quite a one-to-one mapping, but closer to a one-to-one mapping of, okay, this IP address belongs to Vanderbilt University. The information we can derive is this is probably a person who is a student, faculty, or administration at Vanderbilt University. Today, if you go to Vanderbilt University's website and you're just looking at the IP address, it is in all likelihood going to be an IP address owned by Google, Amazon, Cloudflare, Fastly, or one of a handful of companies. So now, people sitting on the line in the early 2000s, mid 2000s, can no longer see the contents of the HTTP request. They can also get the IP address, of course, because you pretty much always can, but it is not as useful of a piece of information. And of course, as these CDNs get more and more customers onto them, it's pretty not helpful to know which CDN they're using. Amazon, of course, runs large swaths of the internet. Google, I think the last stats were 33% of traffic on the internet is going to or from a Google data center or to or from a Google Edge. Cloudflare says they have 10% going in and out of Cloudflare of the daily web traffic. So there's so much noise there. It's pretty difficult to resolve what actual site or destination a user is going to, whether for benign or malicious purposes. So I want to go back and correct a slight error in my, or overlook in my earlier slide, which is the TLS connection, the TLS handshake prior to TLS 1.3, which is still just now starting to see widespread adoption. The server name indicator was actually something that happened at the beginning of the TLS handshake to indicate the host name that the request was being sent for. Now, in the earlier days, when there was close, not exactly, but closer to a one-to-one mapping between IP addresses and host owners, it wasn't a big deal because if you had the IP address, you could pretty easily derive the host name anyway. With all of the CDN networks that have become popular and widespread, this is actually a really useful piece of information that is not easily derivable throughout the rest of the HTTP and TLS handshake and connection. So the fact that this handshake sends the host name in the clear is problematic. So this was recognized in TLS 1.3 includes ESNI, which is encrypted server name indicator. So we go from this to this. Yeah. So
sorry, can I just ask a question?
Sure. Yeah.
I mean, my understanding, and maybe this is completely wrong, was that ESNI, which I think is now called encrypted client flow, is not dependent on a specific version of TLS.
I will confess that I am not intimately familiar with how that is integrated. It does make sense to me that it's I believe it started off as being an add-on or whatever TLS is. Plug-in add-on.
It's in a TLS extension, yeah.
Extension, thank you. Yeah, my understanding was that it is an extension and that TLS 1.3 mandates the extension, but I could be wrong.
No, that would make sense. Okay, thanks for that.
Sure, and yeah, absolutely, definitely double check me on that, because I do confess that some of the inner workings there I'm less familiar with.
If it helps, Eldridge, I think I'm right in saying certainly for the latest version of ESNI, which is ECH, that does require TLS 1.3.
Okay, cool. Thanks, that makes sense. Cool. Any other questions on that? Cool. So ESNI is coming, which makes pretty much the entire HTTP interaction not helpful for someone sitting on the line. They can't get information out of it other than the IP address, which is no longer useful, and they can't manipulate it, assuming that the HTTPS connection is established correctly. So middleware through the years has had quite a few options, and I'm going to be using the words middleware throughout this talk, and I'm going to be using it without judgment. This applies to benign and malicious types of middleware. But I'll definitely be calling out some malicious ones in a little bit. So middleware through the years could look at the DNS query, could look at the destination IP address, the HTTP connection itself, or look at the SNI header before ESNI. Today, those three things are no longer as relevant, or at least in the case of something like ESNI, are looking to be extremely less relevant in the coming year or years. So there was so much info in HTTP that a lot of middleware focused on that, and even as the scope was reduced to the pieces of it that were useful, it stayed in HTTP. And anyone wanting to protect your connection, protecting DNS wasn't particularly useful as long as these concerns in the HTTP piece were not addressed. So today, though, most of the HTTP pieces have been addressed in some capacity. So one of the last pieces of information leakage, so to speak, is the DNS query itself. It's the only thing left. So that's why we're seeing DNS encryption come to the forefront of conversation 37 years after its invention, as opposed to HTTP, which is closer to 10. So now I do want to talk about middleware, and there's lots of different types of middleware, and some of them are benign, some of them are malicious. They basically work in identical fashions. And it's just the
Why has Harley got bleach?
I'm sorry, say again?
So I think somebody was unmuted, didn't realize. Do carry on.
Okay. Cool. So yeah, so middleware works identically, whether it's benign or malicious. Benign, this is things like, for instance, Cisco Umbrella or Cloudflare Gateway, I think their product is called, but ways to aggregate data from people using your network so that you can see if data is leaving, if DNS queries are going to problematic locations. A consumer example is if you use something like Ubiquity for your home network, you can see IoT devices calling out to areas that you would prefer them not call out to. So if you are a middleware operator, a benign middleware operator, it gives you visibility into traffic on your network. It allows you to do malware blocking. If it's calling out DNS requests to a known malware provider, you can just override the response and respond with 0000. Also allows data loss prevention. And then on the malicious side, you have tech working the exact same way, but for people with different motives. Non-stakeholder data aggregation. So this is, for instance, if an ISP like Comcast or AT&T wanted to just monitor your DNS traffic and then sell your data, they would be able to do that or use it for other purposes, even if you're not using Comcast or AT&T's DNS services, as long as you're on their network. Response alteration, a big problem I have with AT&T personally is that if they don't have if you're using their DNS servers and they don't have a record for that DNS request, they will just redirect you to a page with ads, which breaks the specs, but I don't care. And then of course reconnaissance, this is a little more for people that are attacking someone specifically, but you're able to just learn lots of information about an organization. If you can see their DNS queries, oh, they have a lot of queries going to O365, we could probably infer that they're an O365 shop or G Suite or what have you. But these work the same ways, and as we move to encrypted DNS, I believe that we can protect the benign interceptions while preventing the malicious interceptions. Yeah. So we've got some new standards. Y'all are of course familiar with this. We've got DNS over TLS, DNS over HTTPS. DNS Crypt has also been around for a while. I'm not going to be talking too much about that. And the honest reason is I don't know too much about it. But it's been around for a while, and DOT and DOH, in my experience, are seeing much wider adoption and acceptance, but it's worth calling out that exist. So some of the new concerns that I'm seeing around encrypted DNS, there's a lot of them, but I tend to break them in my mind into three categories. The first one is centralization. We're centralizing DNS into a handful of service providers. So 5 years ago, your DNS would go to your local ISP or your university, or whatever network you were on would either use an upstream provider of their choice, or they would run their own. Now we're centralizing as people move to DOT and DOH. You're seeing it centralized into Cloudflare, Google, Quad9, and maybe a few others. Which is, of course, defeats the purpose of having a distributed system. Distributed into just a couple of nodes is almost as problematic as only having one node. Reduced visibility for benign network operators. Of course, if you're trying to sit on the line and read stuff and it's encrypted, can't read it. DNS in layer 7. This is kind of unprecedented. DNS is being removed from the, or not being removed from the system, but certain applications such as Firefox is the prime example, are not relying on the system for DNS resolution. They are instead implementing their own DOH implementation and doing their own DNS queries, which of course bypasses any DNS security that's applied either in the system itself or on the network itself. So yeah, I want to tackle each of these individually. Centralization, I definitely see this as a pragmatic reality and not an inherent function of DOH or DOT. So there are several consumer-focused organizations out there, Mozilla and the Firefox company being the prime examples here. And they're trying to protect their consumers. There are currently known instances of major ISPs performing data aggregation. Firefox wants to work on behalf of their consumers, so they're going to encrypt stuff so that it can't be read by people on the line. And when they do that, there are only a few options, providers to choose from at this point. We are also seeing other systems do it. If you have any of the Encrypt Your DNS applications that are available, they're going to pick one of these few providers because those are the providers, those are the only ones that exist currently. So that is really due to people being very focused about their privacy and lots of consumer applications being focused and pitched on the ideas of user privacy. But there not being a whole lot of servers that support this. I think there are not a lot of servers that support this because there aren't a lot of client operating systems that have it built in natively yet. So that's kind of my take on centralization. That is a concern. We should be concerned about it, but it's not something inherent in DOH or DOT, of course. It's just a pragmatic reality as people start to focus on privacy. So reduced visibility. This is one where enterprises or other organizations are wanting to do enterprise monitoring. So they want to make sure that their data is not being mishandled. They also want to make sure that the responses that their users are getting are valid. DNS redirection. This is particularly useful for IoT devices if you're enterprise or consumer IoT. If your IoT is hard-coded with a DNS server that is run by the IoT company or one that they're licensing out, you can just silently redirect that. The IoT device will think it's gotten the DNS back from the server, that it requested, you will of course be in the middle and manipulating that traffic as needed. So of course, encrypted DNS is a problem for that. You're already seeing this, for example, Chromecast already uses DOH to Google's DNS servers. So of course, it's a very Google device anyway, so it's not as much of a problem, but you can easily conceive of something like a device that downloads new ads or potentially downloads malware, depending on how secure the parent company is. And DNS is a control plane. Is another thing where if it goes out to an address that you don't want it to, you can just never respond to the DNS request or respond with a 0000 response. And moving to the application layer, this is kind of what I mentioned earlier. Slow inroads at the system level cause some applications to include it. Firefox doesn't necessarily, I won't say they don't care about the DNS ecosystem at large, but their priority, as they say it, is for the security and the privacy of their consumers. So if Windows and Mac OS are not going to implement more secure DNS as the Mozilla Foundation sees it, then they're going to implement it in the application. So for consumers, that's a major privacy win. For network operators, that's a security loss. Just as an example, I was, before quarantine, I was in the Duo office, which is running on a Cisco network now. We use Cisco Umbrella. And I couldn't get to a particular page on my Chrome browser. So I switched over to my Firefox browser and it worked just fine because Umbrella was actually denying the DNS response correctly. So it took me a minute to identify why I couldn't get to the page. But that was something where I just, by nature of having Firefox installed, I was able to bypass some of our security protections there. So what are our next steps to kind of address these issues? First off, more OS support and more provider support. As people are using Windows, Mac OS, iPhones, Android devices that support these services and servers, there's going to be higher demand or more willingness to support from network providers as they'll be able to get all the benefits of encryption. And enterprises are going to want this too, the ones that at least that run their own DNS servers, so that they can still do all the DNS control planning they want to do without interception being an issue. So this is what, this was my tool that I open sourced at Black Hat. And I do not have a demo video ready. Oh, no, I actually put it in the slides. Look at that. So I'll play this real quick. I will, and let me preface this video a little bit by saying one of the problems in the earlier bit that I was talking about was the centralization. So of course that happens because you have these applications that have a few providers, Cloudflare and Google listed, and you turn your service on or off. Even if your local network via DHCP issues a DNS server that supports DOT or DOH, it is not something that your system knows how to handle. Even Firefox, which supports DOH, is not going to know to actually use that service. So what Vimes does is it just sits in your system tray. And if you get a DHCP lease with a new DNS server, it'll run a test on it, see if it supports encrypted DNS. If it does, you can click upgrade and it will spin up a core DNS instance locally on your machine and upgrade all of your DNS requests to an encrypted version while still using the DNS server provided by the DHCP lease. So you're not overriding network operator wishes. So you can see that I'm on Xfinity Wi-Fi, which is an open hotspot that uses Comcast's DNS servers, which at the time of recording did not support DNS encryption. So I'm going to use Cloudflare's little test page here. You can see that I'm not connected to their DNS. I'm also not using encrypted DNS. Now I'm going to switch over to Eldridge Guest, which uses Cloudflare DNS. And so I will get a new DHCP lease with a DNS server set to 1.1.1.1. And you'll see the Vimes icon there turn yellow, which means the server supports encrypted DNS, but I'm not using it. So you can see I'm connected, but no encrypted DNS there. I'll click on Vimes and click upgrade. It'll turn green, indicating that it's spun up the core DNS server and actually done the connection. And you'll see now that I am using DNS over TLS to Cloudflare servers. This will work on anything that supports DOT at the moment. So even if you're running a local DNS server locally in your home, that will work as long as it supports DOT. So I submitted this talk to Black Hat about 3 months ago. That's obviously a lot of time in the internet time. So some things that have happened since then is at the time I wrote this talk, Android 9 was the only operating system that natively supported any encrypted DNS, and Android 9 did not have a wide market share. Since then, Microsoft has included it in their insider ring. Apple has announced it for the next versions of macOS and iOS. Firefox and Chrome both integrated directly. Vimes is nice, but it's going to be built in native in a few months anyway, so that's fine. Also, curl supports it. Comcast and Cox have announced support. I don't know if it's actually active yet. Hurricane Electric, Cisco Umbrella, Core DNS, and Quad9 are other services that have either announced or already deployed DOT and or DOH support. So my conclusions are DOT and DOH removed and added some concerns. It moved the control plane to only the DNS server and the endpoint, not in the middle. New concerns are less entirely new and move more a move of where that functionality actually has to be performed. And I think that the benefits of encrypted DNS can be realized without sacrificing a whole lot of control that enterprises have over their networks. As long as these legacy approaches are modified, we don't expect them to just keep working as is. Yeah, so that's my no talk. Happy to answer any questions, comments, concerns. Tell me I'm wrong.
Thank you, Eldridge. And out of interest, how was that received at Black Cat? Did you get much interaction afterwards? Many questions?
A few questions. Most of them were around things I hope I've clarified a little bit more today around some of the history around moving to HTTPS. There were some questions around data exfiltration via DOH versus DNS that I confess I was not familiar with the data exfiltration concerns. I was familiar with the concerns, I wasn't familiar with the methodology. So I didn't have a good answer, but I need to spend this week looking into stuff and getting up to speed on that. But yeah, no, it was pretty well received. Always concerns around, going for enterprises that want to keep stuff in the clear so they can continue to manipulate it in a benign way. But yeah, overall, pretty well received.
Now, I suspect one or more of the ISPs might want to jump in just to clarify. And I can see Ralph has raised his hand as well. But Glenn, do you want to come in first just to clarify the Comcast position?
Yeah, hi, Eldridge. So for full disclosure, as I say, I'm Glenn Dean from Comcast. And one of the things I do in Comcast is help lead the Enterprise Deployment Initiative, EDI, both inside and outside Comcast for encrypted DNS, or encrypted DNS deployment initiatives. My apologies.
Nice.
A couple of points about your talk. Number one, early on you cited Comcast as an example of somebody who might want to look at your DNS traffic. Let me state, we don't. And if you look in the chat, I posted a link to our DNS privacy policy, which clearly and not in legalese states we don't. So that example.
Cool, thank you. I really appreciate that.
And as a customer of ours, because you're using our Xfinity Wi-Fi, you'll be happy to know that we in fact do support DOE for all of our customers and have now for, gosh, I think it's almost 6 months. It's been slow rolling out as a full production service, but it's been available there for testing. And we are integrated with both Google's auto upgrade and now we're part of the Firefox TRR program as they roll out that and turn that on within the United States. So trying to do our part and trying to enable us. The other thing I found surprising though, in your example, as you talk about like the impact of DOE to enterprises, enterprise security, the example you give was that you try to get out through your corporate network using the corporate DNS. And when the corporate DNS stepped in and blocked you from a site that, I'm assuming for a proper reason, the Cisco didn't want you to go to, your response was to switch over to DOE and bypass the corporate security controls, which is one of the big concerns that people have with DOE deployment.
Yes, and that was I should have clarified that. I did not do that in an effort to circumvent my corporation's security controls. I misunderstood what was happening, and I switched over to another browser. And it took me a second to realize why one browser worked and one didn't, and it was the DOE. I certainly don't encourage that type of behavior knowingly. And the reason I brought up that example, though, was, as you say, that's an exact concern I have, is because Firefox decided to upgrade my connection to DOH. Either I turned it on and forgot, or they did it without notifying me, probably the first one, is that they were routing all of my connections to Cloudflare, which of course doesn't provide any security filtering on their, at least on their like 1.1.1.1 service. So what I'd love to see is either Firefox somehow handshaking with the operating system and going, oh, you already took care of DOH, cool, or Firefox going, hey, your version of macOS doesn't support DOH, but we see that the server you are using for DNS does. We're going to continue to use DOH, but use the server you're using so I could get the protections of Umbrella. So yeah, to clarify, that is my concern. Is I agree completely with the concern of DOH using to bypass corporate security. I think that in software developers and browser developers specifically, they could handle this better. But I think given that a year ago when Firefox was thinking about this, Cloudflare and Google and Quad9 were it. They made an okay decision where they were at. I think now we've got more info and there's more context and there's more support. They need to make different decisions, in my opinion.
So I'll call it to your attention. There's a group over at the IETF, which I chair, called ADD, and it's actually working on the question, and a lot of people in this call are participants in it, and you could be too, because it's easy and free. The question about how do you do discovery and how do you convey the information about what the resolver that you've discovered will and can do. You might want to check that out. And finally, and I'll yield the floor, as they say. The other example for the blocking that people are very concerned about is very much around child filters for access to pornographic material. And I noticed that that was absent in your conversation, in your decks as examples. It's something that a lot of people still parents remain very worried about, the ability to suddenly bypass parental controls at various levels and suddenly get all the scary that is on the internet.
Yeah, that's definitely a valid concern. In prep for this talk, this being the corporate security track, my goal was mainly to persuade enterprises that think that DOH and DOT was going to kill everything useful, was to persuade them that nope, this can still be useful. So yeah, I was absolutely thinking of enterprises, not the consumer use case. I have not spent a lot of time thinking about that. That's a really valid point. Thank you.
Thank you. Right, Ralph is next. Ralph.
Okay, so
yeah.
So I mean, the fact that you listed a lot of people who can theoretically support DOE and DOT, but they all do it differently, which is sort of the problem that we have at the moment, that you have no idea if you're using DOE or DOT or what is using DOE or DOT. And I mean, I'm gonna second the plug that Glenn did. We really need to get our act together in the ADD working group and define one or more standards to actually have this sort of automatically upgraded to the same resolver that you're using. And the question I have was with regards to the program you did, where you, I believe, did upgrade to DOT, right? So what kind of TLS checking did you actually do? Because if you upgrade on an IP address, either the IP address supplies the subject alternative name, which is hard for an RFC 1980 address, or, I mean, it's just opportunistic.
Yeah, so I'll be entirely honest with you. At the beginning of developing Vimes, there was no broad support. Once I got into it, Microsoft and Apple had announced broad support, so I did not anticipate a whole lot of actual usage of Vimes. So it doesn't do it very well, just to be frank with you. There's some lists of like known host names, and it tries to, yeah, I think just opportunistically,
so it's similar to the mechanism that Google has, where you have sort of a list of IP addresses to names, and then you check the name for that TLS cert.
Yeah, and so that was the goal was to have a system like that, and then eventually move to better and saner testing. Now that Microsoft and Google and Apple are doing it natively, I'm probably going to leave this as a proof of concept code. unless I see people actually, unless there's like a huge Windows 7 deployment that would benefit somewhere. But yeah, it doesn't do it very well, and I am leaving it as proof of concept code on purpose because I anticipate, unless I see differently, that Microsoft and Apple are going to just integrate it, and that's going to be it.
Great. Thanks.
Okay, thanks, Ralph. Next was Paul Vixie. So, Paul.
Hello, good morning. Thank you for your talk. Thank you for getting involved in all this. I've put a link in the chat to a keynote I gave at NANOG in Texas last year. Strongly recommend you take a look at that. The enterprise threat is harder to dismiss than a lot of people are giving it credit for. In particular, since DOE was literally, according to its abstract, designed to prevent on-path interference in DNS operations. That creates an opportunity for intruders, malware, poison supply chains, etc., that becomes really expensive to block. And exfiltration is only a small part of that. So again, I'd recommend taking a look at that, and I will apologize in advance for how much coffee I had evidently had before giving that keynote. But I'd love to discuss your thoughts after you see that. I do hope that you remain engaged both with the EDDI team that you're speaking to now, and that you become engaged with the ADD team in the IETF, because your perspective is valuable and your testing tool is valuable. So thank you again.
Cool, thanks. Yeah, I'll add that to my watch list today. Thanks.
Okay, thanks, Paul. John Todd, Quad 9 was next.
Hi. First, I'm going to also echo Paul's comments. The Vimes tool is really interesting, and I'm sorry that I didn't know it existed earlier. Otherwise, we'd be actually kind of promoting that a little bit. I wanted to, I guess I'll probably echo some of Paul's comments as well. You stated that this presentation is to make enterprise operators more comfortable with DOE and DOT and even DNS Crypt. And this is perhaps my bias showing, but I kind of got the opposite from that discussion. And most telling was a quick comment that you made about using open, or the umbrella system, that you bypassed your essentially your local umbrella implementation and were using Firefox, and you went to a website that was blocked, and then you had to discover why it was blocked. And that really, a quick comment, I think, would be most concerning to pretty much all the enterprise administrators in your audience, who would, of course, their heads would explode, where you just said, oh, I just went to a virus-ridden site and I just bypassed all my corporate security. Am I misinterpreting your comment? I mean, is that something that really shouldn't be concerning to enterprise operators, or is really DOE and DOT on a centralized model benign, given that statement?
So first of all, let me clarify that I have a habit, good or bad, of speaking extemporaneously. That is not something, that comment about umbrella was not something I included in my Black Hat talk.
Sure.
So it was not in my script that I
but
deviated from. But no, you have a really good point. Yes, absolutely. The thing I was trying to get across there was that it wasn't like umbrella was this overreaching, I really needed to get to this site. Umbrella, like I'm back in high school and umbrella prevented me, and now I'm going here because I wanted to watch YouTube videos. It was a bad site. I, as the consumer, didn't want to go there. Cisco, as my employer, didn't want me to go there, and yet I was able to bypass it because Firefox made the unilateral decision to upgrade my DNS request to a service that. So in that sense, it was bad. But what I was trying to harp on was the unilateral decision by Firefox to upgrade, rather than a more nuanced approach where I can get all of the benefits of umbrella, but not get the maliciousness of a middleware operator that was, like, for instance, my laptop's on umbrella and I'm on my home Wi-Fi, but if I connect to my neighbor's Wi-Fi, then they could obviously intercept it. And so yeah, that was kind of was my attempt to make a point there was. Sure. Firefox shouldn't have unilaterally made the decision. We can get all the benefits of umbrella as long as we figure out a way for Firefox to not override my, or any application to not override my system DNS settings from DHCP.
As a follow-up to that, do you think that it's going to be difficult to disambiguate the connection or the linkage of automatically sending queries to centralized servers from the encryption model itself, which is more neutral? Is that going to happen in your opinion, or how do you see enterprise operators as viewing that's currently a very strong link between those two events and technologies?
Yeah, I am hopeful, given that Firefox is such a, like, their whole shtick these days is consumer privacy and protection, which I'm for. I don't know that we're going to see the genie put back in the bottle for Firefox. I'm hopeful that other browsers that enjoy a more enterprise deployment more often, Chrome and Edge and IE. But Chrome, for example, to my understanding, I haven't dived deep in. They do a lot with some of their enterprise, whatever the G Suite equivalent of GPOs are, to how they deploy their Chrome DNS settings. So they upgrade, but only based on if they think it's a good idea. And I've forgotten exactly how they determine if it's a good idea. I'm hoping that we'll see Firefox's like enterprise browser deployments start to support those types of decisions. And I suspect that Chrome and Edge will always and only support those types of decisions. So yeah, I think we're gonna have trouble putting the genie back in the bottle for any one that is very consumer focused. But I think for enterprises, we're gonna see options where, like, if Firefox detects this in the host system, it will not make that decision. And Chrome and Edge are already doing it, to my understanding. That wasn't a super clear answer, but hopefully that's kind of okay. My thoughts where I'm at.
Thank you.
Sure.
Okay, and just to clarify on that before I bring Roy in, Firefox does auto upgrade to DOE in North America. It doesn't currently do it anywhere else, and I don't believe it could do it in Europe because the TRR policy is not GDPR compliant, which is quite a significant barrier for
Did
Europe.
not know that. Thank you.
Okay, right. So Roy from AT&T is next. So Roy, do you want to jump in?
Thanks. I just wanted to accentuate what Mr. Todd just said. The big concerning thing to me is that he was able to bypass policies that were being applied by his umbrella DNS server. In the closing slide of his presentation, he stated that legacy could cope with this somehow as long as it was willing to be flexible. I'm not sure. The changes that he just proposed here would be changes to Firefox, nothing that legacy could do.
Well, one thing I wanted to, and I might have should harped on this a little more, but I think as long as we have users able to have a certain level of control over their own endpoint, this is a risk that's going to manifest in a variety of capacities. And I think Firefox making this change would make it easier and would be a good decision. So I do advocate that. But I think also strong endpoint control is something that has to be done and should be done anyway, but it's a whole separate concern. But as long as I can install anything, like Firefox is not distributed by my corporation. I downloaded and install it from my personal email. If the endpoint control was stronger, which Duo likes to let people manage their own endpoints, and collect data rather than enforcing things. But this is an area where I think we could see maybe a little stronger enforcement, even in companies that don't necessarily like that. Is, hey, are you installing Firefox? Great, we're going to flip this enterprise control. Or, in companies that are maybe a little bit more locked down necessarily. So, hey, we're not going to let you install an application that supports this type of thing. We're going to either have an allow list of accepted binaries or a deny list of known DOH overriders. Because at this point, because I have so much control over my endpoint, if I didn't have the Firefox DOH option, I could have installed WireGuard. I could have done lots of other things because I have so much endpoint control. DOH was just how it happened to manifest. I think Firefox should make that happen less transparently to the user. I think they should make it more obvious what they're doing, especially if they can detect they're an enterprise. I don't think that someone that has root on their own endpoint is ever going to be blocked from accessing a thing.
You're focusing in on the enterprise issue, which is where you experience this, but it's true for consumer policies as well, and that we don't have control over. So unless Firefox does in fact enforce this policy of not changing from your default DNS server, unless it knows it's not going to invalidate your policies, I don't see how there's anything the legacy system can do.
So I guess just to clarify my understanding, the theoretical implementation here would be an ISP like AT&T putting on like parental controls or some type of DNS control, and if the end user selected a different DNS server that was unencrypted, AT&T would still read and rewrite the DNS queries if they were resolving to somewhere on AT&T's deny list. Is that and then DOH would obviously prevent them from being able to do that. Is that the concern?
Right.
Okay.
And customers have always been able to manually switch away, but we kind of rely on the fact that the average consumer doesn't know how to do that. When the browser is going to do it automatically, then it's a much bigger exposure.
Yes, and yeah, I absolutely agree. And I don't that's one of the reasons I think browsers and applications either should detect that they're running on an operating system that supports native DOT or DOH and not touch stuff, or do some other type of acknowledgement that, hey, this upstream DNS server is supporting of this. So yeah, I don't have a good answer other than, yeah, browsers should be a little more respectful. Browsers should definitely work to secure the privacy of their end users, but they should also be respectful of network settings. And I think at the time Firefox made the decision they made, where almost nobody was supporting DOH and DOT, and there were concerns, they did the best they could. But I think a year or how much longer later, we're seeing much broader support, and I think they should make it either default to what's issued by DHCP or just make somewhat better decisions. So I don't really have an answer other than I agree with your concerns. I would like to see browsers be a little bit less authoritative on that.
We were talking earlier about the need to standardize DOE. My hopes are more along the lines of a standardized discovery protocol.
That makes sense.
Thanks.
Right. Thanks, Roy.
Thank you.
Just conscious of the time. Any last question from anyone? I can see no virtual blue hands. Anyone else want to just quickly jump in? Otherwise, we will move on. No. Well, Chris Box in the chat has posted a link to the Vimes GitHub on Duolabs. So I guess Eldridge on there, that will give the sort of bring to life the example that you very ably demonstrated just now for anyone that's interested to learn more about that. Yeah. So on that point, thank you for the presentation. That was very much appreciated, Eldridge. If you're able to share the slides, that will be useful, and I'll circulate those
Certainly.
Afterwards, as well as a link to the recording, which will be on the YouTube channel. So thank you for taking the time out to reprise last week's presentation. That's much appreciated.
Yeah, thank y'all.
Okay, right, and you're welcome to stay on, I should have said. Very rude of me not to, or to disappear if you've got other calls on your time. But we're now very much on any other business. So is there anything that anyone wants to sort of just jump in on in the last sort of 5 minutes or so of the call? Otherwise, I've got a question for Glenn, which I'd forgotten to email him, so I will ask him whilst he's there. It's a very easy question. But Adam wants to come in first. He's raised his virtual hand. So Adam, do you want to just come in first? I'll give Glenn a chance to sweat as to what question I have.
Hi there, Andrew. I don't know how relevant this question is, but it's just a thought of something that's cropped up quickly in the UK, at least, in that UK ISPs are in conversations with our government here about the Google Apple app for COVID, which I assume that privacy is a big part of it. And government has asked us to zero rate data of users using that app. And I was just wondering, as a non-technical person, whether that is likely to be challenging to do. And I have no idea whether it is or isn't, because of encryption that might be embedded within that app. So yeah, that was my call out to the rest of the group. If anyone has any views on that.
It's Chris. So you're right, Adam. Yeah, it is a problem. It's mainly a problem because of the combination of ECH, encrypted client hello, and actually it's a problem even before that. So the problem is, if you want to zero rate something, you have to identify it. And if you're identifying HTTP traffic, you're looking at the SNI. The SNI is not a guarantee about the contents of the encrypted tunnel. So we have seen fraud cases where people just tunnel traffic through the network to their own server, but they put on the outside of it an SNI that says, this is some legitimate free service, but it isn't. So that goes on. Normally you can use DNS to spot that because you can correlate it with DNS queries, but when DNS is encrypted, you can't. So yes, it opens that issue, and it really goes to the whole broader thing of how much network visibility should there be, because it's difficult to find that right balance. And if you make everything private, then everything has to be charged for, or at least it all has to be charged for at the same rate.
So a non-trivial problem, in other words, Chris. I thought you might jump in on that one, but yeah. Rather neatly illustrates the problem of, as you said, the more you encrypt stuff, the harder it is to then differentiate it.
Yes.
Fine. Right, let me ask Glenn the really simple question. This is with your co-chair hat on, Glenn, so this really is an easy question. Which I forgot to email you about on Friday, so apologies, which was the ADD GitHub. Is that going to be christened this week, do you think?
You're getting a little bit ahead of me. I was just setting it up last week, so it's very, very brand new. Let me finish getting it set up. My thinking was, and I've emailed Chris about this, is I think we'll pull Chris's requirements document that he's trying to pull together into there as the first project, and I'll be creating a repository for that and letting everybody know. I'll pass on to Chris, and then Chris can let everybody know. But thinking that might be a good first place to start doing that work, because I think having some decent diagrams is going to be essential, and getting them out of the IETF line art may be a little bit easier to have discussions and should make changes to them than the line art version. So yes, it's coming.
Fine. Brilliant. Thank you. And I can see whilst we're talking rather helpfully, I see Brian has put on some further thoughts about zero rating traffic if it goes to a dedicated IP address, which again, I guess presupposes that the DNS isn't encrypted, or to use DPI, I think is Hamilton's suggestion. Although I know
DPI is I'd say non-deterministic. Yeah, it's sometimes it can identify something, sometimes it can't. Dedicated IP addresses, yes, you can solve the problem that way if you know that a particular IP or set of IPs is the service of interest. But yeah, as Eldridge was saying earlier, that's pretty rare these days when everything's on CDNs.
Yeah. Otherwise, hopefully you can't solve that, because otherwise it looks like I won't be able to get away with my free a special Netflix-like service with excellent one careful owner content for special rates using spoofed SNI data.
Well, I work with several CDNs that will offer you a dedicated IP address. So, you know, you can always reach out to me if you need a provider.
So that might be a conversation to push back to the UK government.
Well, and by the way, Andrew, on this topic, I believe there have been instances where Cloudflare, in order to comply with court rulings, has actually moved services to dedicated IP addresses as well. So clearly that demonstrates they have the technical capability.
Okay.
Now, whether you'd want to deploy for this, that would be their decision, but the ability exists.
Yeah, perfect. So that might be a conversation then to have with Apple and Google to see if they'd be prepared to use a dedicated IP address, or indeed, just I'm following on the chat, Hamilton's suggestion of DPI as an alternate option, which I'll leave you to explore directly with each other if that is of interest. Right, our time is almost up, so any last minute point anyone wants to raise? I'll take that as a no. I can't see anything on the chat, with no virtual hands are raised. So on that note then, thanks everyone for your time. Thanks again, Eldridge, for your presentation, which is very much appreciated.
Yeah, thanks for having me.
And have a great week, everyone. Hope you don't get too hot, like I'm here. So I'm going to go and have a very cold can of Pepsi Zero. Thanks all.
Thank you, Andrew.
Have a good week.
Thank you. Thank you, Eldridge.
Bye.